Hello everyone and welcome back to Lee's R&D with Terrain Sessions. Now this is, Lee, I don't know, what should we call this? This is session 2 of your R&D with Terrain. Does that sound good?
Yeah, that works. It's a continuation of what we did last time, and we're even going to continue right where we left the code off so you can see the next iteration.
Now, as a quick reminder to those that are watching, we are doing this over a great deal of distance, about 700 miles between the two of us, so we are using a few different technologies that can from time to time give us grief, and this is also us doing something that involves a lot of heavy graphic draws back and forth, i.e. if we pull up the terrain right now, it's going to get a little bit slow and choppy on the feedback that goes back to Lee's connection. So I just wanted to point that out from time to time. Lee may need my help, such as operating the mouse and the keyboard when running over terrain. Just in case you hear anything that sounds odd, I just wanted you to be aware of what was going on. Also, as a reminder that in these R&D sessions, no code that is being typed out is final code. This is nothing more than taking a look at some of the findings that Lee has stumbled on through his R&D over the past week. He's been posting screenshots over in the MMO class, and there's been a lot of you out there that have been interested in what he's doing. So now it's time for us to take a look at exactly what he has been doing, but following line by line through the code. So Lee, if you don't mind, in this quick introduction here, give us an overview of what we can expect here in session 2.
Okay, well, what you've got is, or what you're about to watch is the distilled process of the R&D research that I've done over the last week. If you were to sit down and, kind of look over my shoulder as I've done it, you'd be really bored because it was hour upon hour of trial and error, trying different algorithms and different techniques for generating terrain. So what you get to watch in this set of videos is the culmination of all of that research. And, you know, you won't see everything that we've got in some of the screenshots that are in the work in progress. This particular set of videos are going to take you from where we left off last time all the way up to having the new world terrain generation in place with most of the features. I'm not going to get into the texture that I put on the world there. If you want to experiment, we'll leave that up to you. And we're also not going to be getting into the sculpting of the terrain in this set of videos. That will be in the next set. What
Right.
we what we will be covering here, though, is over the next several videos, we're going to go in and we're going to clean up some of the code that we did in the last video to get it ready for this next set of implementation. Then we're going to take a look at changing the terrain patches from having their pivot point in one of the corners to actually having the pivot point in the center. We're going to look at making an array of these terrain patches, and then we're going to look at making those scrollable. So you'll be able to walk through them and the terrain will expand in the direction that you're moving. And then after that, we're going to get into the new technique that I have implemented for generating the terrain dynamically with using a very, very small set of source data.
Okay. Very
So,
cool. So that's pretty much it. Just a quick reminder for those of you that may not have seen the last R&D session anytime recently. This is where we left off last. If we jump in here, or
well,
there we
it's
go.
it's got to
Yeah, it's
calculate.
exactly. And if you want to take just a second, remind them. Why does it got to take that second to calculate, Lee?
All right. Well, the terrain you're looking at right now is based off of a prototype experiment that I was doing with a terrain generator. This is using pseudo-random numbers and a bunch of different techniques like Voronoi and Perlin, smoothing, erosion to come up with this terrain. It's a very slow process, which is why we're not going to use it in the game. So, or in the R&D. What I've done is come up with another technique that is using sampling, which is much faster.
And gives us obviously a lot more control as well for a starting point, correct?
Well, yes,
I mean, if we wanted to take advantage of it.
well, the nice thing about using this technique is it allows an artist to come in and grossly define the shape of the world, going, I want an ocean over here and a mountain range over there, and this should be a continent here, this should be some lowlands. The new system that I came up with will be able to do that as opposed to a procedural noise-based calculation, because with what we've done before, the best we could hope is to give an artist a whole bunch of sliders and numbers that they can enter in, and then they'll just have to sit there and tweak and hope for the best. There's no real control over what goes where.
But
So
now we have that control, or we will have that control coming up here very shortly.
yes,
Okay,
on a macro scale.
correct. All right, so I think that's pretty much everything that we wanted to talk about here. By the time we get to the end of this session, what's your goal? Where are we going to be at?
Well, my goal is to have a world that will be infinitely scrollable in any direction, with unique terrain out to almost 2,500 square miles.
True.
So
Now that's
fairly
starting.
big.
That's starting from, say, center of this world out.
Yes. So
Well,
basically,
you said square miles. No, so that's
well,
that's
it's the
based
whole
off of
world.
the calculation from the center out, and then you use that for determining what the whole square mile area would be. Correct?
Right. So you could basically pick a direction, start heading in that direction, and you would have to go, I believe it's 73,728 meters
Okay.
before you'd ever repeat the terrain. But by that point, you've seen so much stuff, you probably wouldn't even know it was repeating at that point.
Gotcha.
Now, that is only because of the size map that I started with, and the fact that I don't have any Perlin noise. Now, if I wanted to make this infinitely large and infinitely non-repeatable, I would introduce a little bit of noise
Hmm.
to the process that I was doing, which would ensure that there would be no repeating all the way out to the full test, which I did last Friday, which yielded, I think it was 82 million square miles before it just got to the point where Unity was completely falling apart.
Right. Because of precision, I would take it.
Yes.
Okay.
At that point, I was over 7 million meters from the center.
Wow.
So by the time I hit 10 million, I think that's when one floating point finally breaks.
Gotcha. All right. Well, let's go ahead and wrap up the introduction here, and we'll move on into the next video where you're going to do a little bit of project cleanup. So that'll conclude this video. Thanks a lot.
Thanks.